Hello, my name is Lucas Fredericks. I'm not able to present in person because I have COVID, but I'm going to record a version of it anyway, so I hope you enjoy it. This presentation is about augmented and virtual reality exhibits in museums, some of the traps that exhibit designers fall into that create expensive but underwhelming or inaccessible exhibits, and some of my observations on what we can take away from that, and hopefully create more exhibits that are fun, seamless, accessible, and affordable. So we'll start with a quick definition of terms. Virtual reality is an entirely separate, simulated reality mediated by technology. The goal is to leave our reality and enter an entirely new one. Think Ready Player One, or this classic bit from The Simpsons. And augmented reality is a virtual layer imposed on the existing world that adds more information. Think of the John Carpenter classic, They Live. All right, so let's start with VR. What's wrong with it? This guy. The metaverse, I think, it's boring, it's expensive, it has severe hardware limitations, it's a technology and, more to the point, funding in search of a purpose to exist. It's also mixed up with crypto for some reason, and in my opinion, VR is often not really great for exhibits, but we'll get into that later. So generally, I think AR is much better suited for exhibits than VR. This is an exhibit called Back to the City of the Sun from the Cahokia Mounds Museum Society. And I picked it because it's basically your standard virtual reality, augmented reality exhibit. And I don't want to pick on it because I think it seems pretty good. It helps put visitors in a different time and place and imagine themselves there. And I think that's all to the good, but I think it also illustrates some of the limitations of the technology as it's often implemented. There's accessibility problems, both for visitors and museums. In this case, are visitors going to need to have a smartphone to access it? Are they going to be willing to download an app? Do they have a data plan? Are there coverage issues? This looks like a rural location. Do they have enough space on their phones? And are they going to jump through all of those hoops? And if so, are they going to be annoyed if it's disappointing after they've done all of that? If this is more of your standard virtual reality exhibit, then does it require goggles? How many pairs of goggles can you have on the floor? They tend to be expensive and fragile, tough to clean. In this case, they'd have to be outside. That all takes a lot of facilitation and infrastructure, not to mention the costs of paying a professional to develop this entire 3D world that they're going to be inhabiting. So this leads me to what I call the Assassin's Creed test, sort of a heuristic for thinking about how your virtual reality or augmented reality exhibit is going to stack up against the competition. And the competition in this case is a video game company that has a lot more money and a lot more very specialized staff dedicated to creating these historically accurate virtual worlds. And it exists already in the living rooms of your guests. So how is your exhibit going to stack up against that? And the economics are tricky, to say the least. Okay, so let's talk about what actually does work here. The first is to play to your advantages. Your primary advantage being a central location where you can set up the infrastructure and hardware to work with the exhibit. I think a lot of the reason the metaverse applications of VR technology are so shabby looking is because they're trying to create it for the lowest common denominator of home consumer hardware. You want to think more like an arcade. You have the advantages of this centralized space and the resources, and you want to organize your space so that it works for the exhibit. The next thing is don't fight geometry. Remember, 3D cameras are just cameras with an extra data point. Basically, you have all the limitations of perspective, and you need to set up your space so that it works with the 3D camera. I've seen some AR exhibits that use these hidden 3D cameras near the floor, pointing sort of diagonally upwards into the room. The users don't know where they are. It's not clear where they have to be or how to best interact with the camera. And it's confusing because it's hidden. So you want to design your space with these limitations in mind. Complexity is going to scale exponentially with the dimensionality of your exhibit. If you want like a full 3D perfect representation of your room, you're going to need several cameras. They're all going to need to know exactly where they are in relationship to each other. You'll have to synthesize all of that together into meaningful data, and then that's before you've even done anything with it. It can be done, but it's complicated and tends to get really expensive. We don't even have driverless cars yet, so know your limitations in terms of time and budget and expertise. Remember that augmented reality in particular is a layer of an exhibit. It's not the exhibit itself. And finally, a sort of personal mantra, never show your work. You want it to be seamless, you want it to be hidden, you want people to be able to interact with it without having to think about it. So if you design it properly, or I think in the best applications of this technology, the augmented reality layer sort of disappears. You can forget about it. You can interact with it very naturally. So this exhibit is from Carl Sims. It's called Particle Mirror. It uses a Kinect camera. You can see hidden in the center of the projection wall here, and it has all of these particles that visitors can interact with. So first of all, you can see, even though it's using 3D technology, he's not trying to map the whole room to even necessarily like know what's a person or what's not a person, or anything complicated like that. It's using the 3D depth information just for thresholding in order to ignore the background and the foreground data, and let people interact with it very naturally, which they can do just by walking into the exhibit. And you can't really see it from the slide, but there's also clearly a ton of time and attention went into the different types of particles, their properties, their sound effects, and I think this is just a really excellent, fun exhibit. This is an exhibit that I made. It's a component of a larger exhibit called Life on the Edge. So in this exhibit, you use sort of physical coding blocks to give directions to this rover. The rover steers around the arena. You can navigate it to different locations on the screen. You can see that there's a digitally imposed hexagonal grid, and that is the grid that the users are navigating along. It does not exist in the real world. It's an augmented reality layer. And it uses these computer vision markers both on the carpet and on the rover to do the perspective transformations so that the rover can steer in real world coordinates to end up in places that align with the hexagons in the digital coordinate space. Again, this uses 3D depth information, in this case the data extracted from the computer vision markers, in order to add a layer to the exhibit and augment the user's experience, mediating the virtual and real worlds. It's using the space to its advantage. Just like in the particle mirror exhibit, the camera is not obtrusive, but it's not concealed, and it's located to use the space to its advantage. It has the best perspective to see the arena itself and locate the computer vision markers. Visitors can probably go home and drive a rover around in a video game, but they don't have an actual robotic rover. AR augments the exhibit without becoming the focus of the exhibit itself. It adds a control mechanism, prevents crashes, and it adds goals and obstacles. The exhibit isn't about perspective transformations and coordinate systems. It's about driving a rover, and the AR layer allows that to happen and then disappears. All right, that is my presentation. I hope you enjoyed it. I'm sorry that I'm not there in person. If you have any questions or just enjoyed the presentation, I'd love to hear from you. Here's my email. I work at the Ithaca Science Center. Stop by if you are ever in town. Thank you.